What's up, amazing people? Welcome to this video yet again in the series of stoichiometry where we're going to be handling the gas stoichiometry part. My name's David and I'm an online chemistry tutor for high school kids. Let's see if we can learn a thing or two in this video. So up until this point in our previous videos, we've been working with mass. We've been working with moles, we've been working with mole ratios, we've been working with limiting reagents, excess reagents, and so many other things. Now, in this video, we're entering another interesting part, which is the volumes of gases. We know that not just solids and liquids take place in chemical reactions, gases also have a part to play. So, here's the interesting thing scientists have actually discovered something interesting. When gases react, under the same conditions of temperature and pressure, their volumes combine in simple whole number ratios. When the conditions of temperature and pressure are the same, the volumes combine in simple whole number ratios. That's the mole ratio comes into play. And instead of counting particles, we can compare the volumes directly. What do we mean? Consider this equation on the screen. Okay, now let's say they are in the gaseous state of matter. The coefficients are 2 ratio 1 ratio 2. You can see the coefficient of hydrogen 2. Oxygen has nothing in front, so that automatically leaves us with a 1, and water has a coefficient of 2. For gases, these coefficients also represent volume ratios. Okay, it simply means that the volume of hydrogen over here is in two parts. That of oxygen is in one part, and that of H2O is in two parts. What that simply means is that if the volume of hydrogen is 2 liters, it means the one for oxygen will be 1 liter and the one for H2O will also be 2 liters. So that's for conditions where the temperature and the pressure are the same. So for gases under the same temperature and pressure, the coefficient ratio is equal to the mole ratio, and it is also equal to the volume ratio. So here is one example on the screen. Consider this equation. What volume ratio exists between hydrogen and oxygen? Well, it's simple. Let's pick out hydrogen and oxygen first. We have 2H2 and we also have O2, which is oxygen. The volume ratio that exists between these two is we have the coefficient 2 and we have 1. So the volume ratio becomes 2 ratio 1. The mole ratio is actually the same as the volume ratio. So that's exactly what we're talking about. So the volume ratio is simply the mole ratio in the gaseous state of matter. So let's see some volume to volume calculations. This is the gas version of mole to mole calculations. Instead of using moles, we use volumes. The method is exactly the same. So whenever you see a gas to volume question, step number 1, write the balanced equation, identify the coefficient ratio. The coefficient ratio becomes the same as the volume ratio, and then you solve. Let's take all these steps one by one and see if we can handle a number of questions. The first example, we have this equation on the screen. How many liters of oxygen are needed to react with 10 liters of hydrogen? Let's see the number of steps again. We write the balanced equation, identify the coefficient ratio, set up the volume ratio, and solve. Well, the balanced equation first has been given to us. It's over here. The question says how many liters of oxygen are needed to react with 10 liters of hydrogen. Well, let's set up the mole ratio. How many liters of oxygen? The first we're dealing with is oxygen, O2. And then we have hydrogen, which is 2H2. Let's find out the volume ratio or the mole ratio. So we have 1 ratio 2. This means 1 mole of oxygen, O2, reacts with 2 moles of hydrogen, H2. Now the question says how many liters of oxygen? So we have X liters of oxygen will now react with 10 liters of hydrogen H2 because we're asked 10 liters of hydrogen. At this point, we can simply cross multiply. And when we do that, we have 2x is equal to 10 times 1. X is equal to 10 divided by 2. This gives us 5 liters. So 5 liters of oxygen are needed to react with 10 liters of hydrogen. Can you see how the mole ratio was applied to the volume question? Let's handle another one. We have this question on the screen and they're saying how many liters of ammonia can be produced from 12 liters of hydrogen? Well, let's set up the volume ratio first. How many liters of ammonia? We have ammonia NH3 and we have hydrogen H2. From the equation, the mole ratios are, we have the coefficient 2 and for hydrogen we have 3. So the mole ratio becomes 2:3. This simply means 2 moles of NH3 are produced by 3 moles of H2. Now the question says how many liters of ammonia, so X liters of ammonia NH3 will be produced from 12 liters of hydrogen H2. So let's cross multiply. When we cross multiply, we have 3 times x is equal to 12 times 2. 3x is equal to 24. X is equal to 24 divided by 3, which gives us 8 liters. So the answer to that question is 8 liters of ammonia can be produced from 12 liters of hydrogen. Let's handle yet again another question. We have an example on the screen and it says how many liters of oxygen are required for 15 liters of methane? Well, let's set up the mole ratio first since we have the balanced chemical equation. How many liters of oxygen, so we have O2 first, are required for 15 liters of methane and we have CH4 next. From the chemical equation, you can see O2 over here. We have 2O2 and we have methane just standing alone, CH4. So the mole ratio becomes 2:1. The meaning of that is 2 moles of oxygen reacts with 1 mole of CH4. And the question says how many liters of oxygen, so X liters of oxygen are required for 15 liters of methane. So when we cross multiply, we end up having X is equal to 2 times 15, which gives us 30 liters. So 30 liters of oxygen are required for 15 liters of methane. It's pretty easy and straight to the point, right? Let's check out the next example. The next example on the screen, having this balanced chemical equation, it says how many liters of carbon dioxide can be produced from 20 liters of carbon monoxide? So let's write out the mole ratio. How many liters of carbon dioxide? We have CO2 first, and then we have carbon monoxide, CO, next. From the chemical equation, you can see that both of them have coefficients of 2 apiece. So the mole ratio becomes 2:2. This can be simplified to become 1:1. The meaning of that is 1 mole of CO2, carbon dioxide, is produced by 1 mole of CO, carbon monoxide. And the question says how many liters of carbon dioxide, so X liters of carbon dioxide, CO2, can be produced by 20 liters of carbon monoxide, CO. So at this point, we cross multiply. X is equal to 20 times 1. This gives us 20 liters of carbon dioxide? So the answer to that question is 20 liters of carbon dioxide can be produced from 20 liters of carbon monoxide. Did you get that? So a fast exam shortcut is when all the substances involved are gases, you do not need the atomic mass, you do not need the molecular mass, you do not need more calculations. You simply use the coefficients. This, in my opinion, is pretty straightforward and very, very easy. So the summary of all we've been saying since the beginning of this video is gases occupy measurable volumes. Gas volumes react in simple whole number ratios. For gases, the coefficient ratio is equal to the mole ratio, which is equal to the volume ratio. You saw that done. Balanced chemical equations provide the volume ratios, relationships rather, and then volume to volume calculations use the same approach as mole ratios. And then finally, many gas questions can be solved without calculating the molecular mass values. So here are some practice questions for you to try out your hands on while we await the next video. Feel free to pause the video and write down the questions. Feel absolutely free to pause the video and write down the questions. And I look forward to seeing you in the next one, which is upcoming. Next up, we're going to be handling the molar gas volume calculations. It's been an interesting one thus far, and I trust you got massive value for this. If you did, please consider liking, sharing, and subscribing to this YouTube channel. And I'll see you in the next one. Peace.